All right, welcome to The Explainer. Today, we're jumping into a huge debate in the data world, one that's been totally supercharged by modern cloud technology. We're talking about the very foundation of how we organize data for analysis. So let's kick things off with a question that kind of shakes the foundations. For decades, pretty much everyone in business intelligence and data warehousing agreed on the right way to structure data. But what if the technology has changed so much that those old golden rules just aren't golden anymore?
To really get what's at stake here, we first need to understand the reigning champion, the absolute king of data modeling for as long as I can remember, the star schema. So, what is it? Well, a star schema is this really elegant way to separate your numbers from your story. Right in the middle, you have what's called a fact table. This is where your core numbers live. Things like sales totals, units sold, that kind of stuff. And then surrounding it, you have all these dimension tables, and they provide all the context. Who bought it, what product it was, when it was sold. When you draw it out, it looks, well, like a star. And look, this wasn't just some abstract idea from a textbook. As this data professional points out on Reddit, the star schema became the actual blueprint for business intelligence. It's how you take all those raw business events and wrap them in meaningful context so you can actually figure out what's going on. It's clean, it's organized, it's a classic for a reason. Let's make this a little more concrete. There's this great metaphor from the Data Warehouse Toolkit. Think about your data system like a restaurant. The kitchen is where all the prep work happens, cleaning up raw data. The star schema, that's the final, perfectly organized plate of food delivered to the diner, who is, in this case, your analyst. The final bill with all the totals, that's your fact table. The menu, the customer list, the specials board, those are all your dimensions, giving it context. For years and years, this model was just unbeatable. It was perfectly tuned for the hardware and the databases we had at the time. But then, the cloud came along and completely changed the entire playing field. So, three huge technological shifts just blew up all the old assumptions. First, the insane scale of the cloud. Second, columnar storage. Now, instead of storing data row by row like a spreadsheet, these new databases store it column by column. This makes scanning a single column to, say, average all your sales ridiculously fast. And third, massively parallel processing, or MPP. This is like having an army of processors attacking a single query all at once. It's brute force on a whole new level. And these weren't just abstract concepts, right? They were baked into a whole new generation of cloud data warehouses. We're talking about systems like Amazon Redshift, Snowflake, and Vertica, all built from the ground up to take advantage of this new way of doing things. They just play by a completely different set of rules. And all this new tech basically reignited an old, fiery debate. With all this power at our fingertips, is it still better to use the elegant, multi-table star schema? Or should we just throw everything into one giant, messy, denormalized flat table, where every bit of context is just repeated on every single row? So here's the basic trade-off. A star schema is normalized. It's designed to save storage space by not repeating data. The catch? Your database has to perform joins to piece the full picture back together. A flat table is the complete opposite. It's denormalized. You repeat information on every single row. It eats up way more storage, but your queries don't need any of those complex joins. And for a long time, doing those joins was way faster than trying to scan a gigantic table. Beyond just the raw computer performance, there's a human side to this. As this person on Reddit points out, a massive flat table with like 127 columns can just become an absolute nightmare to manage. It's hard to understand, it's hard to document, and it's nearly impossible to hand over to a new team member. The elegance of the star schema was never just about speed. It was also about making things manageable for us humans. Okay, so theories and feelings are one thing, but which one is actually faster today in the cloud? This is where it gets really, really interesting. An academic study put these two models head-to-head on modern cloud databases to see what would happen. And the results were not what a lot of people expected. For some of the big players, like Amazon Redshift, yeah, the traditional star schema was still king. But for a bunch of other modern systems, like IBM's DB2 Warehouse and Single Store, the giant flat table was way, way faster. The golden rule was officially broken. So, why? What happened? Well, the researchers figured out that for certain databases that are just incredible at data compression and parallel processing, the performance hit from scanning a much larger flat table was actually less than the cost of doing all those complicated joins. Basically, the brute force approach, supercharged by new tech, actually won.
And you can really see this with a system like IBM's DB2 warehouse. I mean, on that platform, the flat table didn't just win, it absolutely crushed the star schema. The performance gap wasn't small, it was huge.
But, and this is a big but, that incredible speed comes at a cost. A pretty big one, actually. According to that same study, going with a flat table blew up the data volume by an average of 4 to 5 times. So you're basically trading storage space for raw query speed.
Which, of course, leaves us with the million-dollar question for every single data architect and engineer listening right now. Given all this, which model should you actually be using for your work today? And the most important takeaway from all of this is there is no longer a single right answer. The idea that you should always use a star schema, no matter what, that's officially a myth. It's been busted by the raw power of modern cloud platforms. The right choice for you depends completely on your situation. First, what tech are you using? That's probably the biggest factor. Second, what do your queries actually look like? Are they simple or super complex? And third, and this is the most important part, test it. Don't just rely on old rules of thumb. Run some benchmarks with your own data and see for yourself what really works best. And that really brings us to the final thought here. The tech in our world is moving at an incredible pace. The assumptions that were rock solid 5 or 10 years ago might actually be slowing you down today. So the question I want to leave you with is this. Is your data architecture built on the rules of the past, or is it truly optimized for the amazing tools we have right now? It might be time to find out.